Good evening, and thank you for your time. My name is Ryan. I am here with Aaron and Kevin. We will be reviewing the Imagine Network merger and its expansion into a wide area network.
Good evening, everyone. So this project focuses on integrating multiple networks while enhancing scalability, security, and performance across various locations. We'll walk you through the technical foundations supporting this transition, including routing design, VLAN segmentation, and strategic scalability plans. Next slide. The core objective is to merge Imagine's network infrastructure efficiently while minimizing disruption. Ensures secure and scalable communication between all sites, and establish a foundation that accommodates future expansions, new technology, and secure data handling. Next slide. Our primary goal is seamless integration of Imagine's network and data center infrastructure. Emphasize the segregation of traffic using VLANs. Each VLAN is designed with clear boundaries and purposes. Spinal leaf architecture is introduced to improve redundancy and increase bandwidth across the data center. This setup ensures not only speed, but future-ready scalability and consistent performance as demands grow. Next slide. So we've chosen a scalable IP addressing scheme using a Class C network with the option to upgrade to Class B if growth exceeds the current scope. The hardware selection includes modular routers with additional NIM ports while allowing expansion without major hardware changes. This design ensures future-proofing as more departments, devices, or sites are added. Next slide. The WAN is designed with EIGRP for efficient routing and ease of convergence. With a /30 slider, we have 58 subnets available of the 64 currently set up, supporting the addition of multiple routers and leaks as well. This allows for increased redundancy and simplified troubleshooting, ideal for a dynamic enterprise network. Next slide. The Imagine VLAN is designed for scalability through modular subnetting and switch expansion. New switches can be deployed without impacting existing operations thanks to forward-thinking addressing and segmentation. This site forms the base of the VLAN model that other sites will follow. Next slide. The Orlando site uses dedicated subnets for key departments, supporting current operations with scalability in mind. We can deploy additional subnets as needed for expansion, accommodating more departments or services. Subnets are assigned to ensure easy route summarization and management with segmentation to prevent cross-site traffic. Next slide. The data center uses a spine and leaf topology to enhance throughput and reduce bottlenecks between servers and switches. Because the VLAN is structured for high throughput and robust access control, it has created additional support for virtual machine traffic, storage networks, and internal services like authentication. This layout provides the option of scaling up to 254 different servers. Next slide. Chicago is our newest integration and is a model for our future expansions. This VLAN incorporates multiple subnets for dedicated departments. The design allows for future scalability, such as the addition of new business units or expansion into IoT. Consistency in VLAN design ensures it integrates smoothly with Imagine's wider network.
So network efficiency is a crucial aspect of any network. So the protocol we have gone with is EIGRP routing. It's a distance vector routing protocol that allows the routers to find the shortest possible path, utilizing a diffusing update algorithm to maintain a loop-free paths and fast convergence, alongside a reliable transport protocol, ensures delivery of all packets. Combining the aspects of a link state protocol, it allows the routers to update the routing tables as well as the topology tables. This does allow for added routers in order to handle increased traffic flow, and prevent latency upon the network. All right, utilizing the spine and leaf architecture within the data center, being a fully meshed topology, it connects every spine to every leaf. This ensures redundancy with high uptime, as well as reducing hop count and latency. This ensures that increase of productivity, that there's always connectivity and access to resources from each respective local area network within the wider area network. All right, next slide. Upgrading from the current hardware that was previously used into with 4321 and 4331 routers, as long as 3650 multi-layer switches. We have allowed for flexibility, a higher bandwidth capacity, as these are also modular in design. You can add in network interface modules as well as service modules to allow for the easy addition of new hardware to handle the increased traffic flow should the network grow. Next slide. Now, with the wider area network behind the firewall, this helps protect the entire network as a whole, as it does present a small attack surface. It would prevent any sort of attack that would be designed to reduce the effectiveness of the network as a whole. There's a dedicated DDoS attack. Each LAN will have a dedicated server where you can also have stored backups, acting as a hot site to reduce the potential for data loss and ensure continuation and productivity within each organization if there should be any sort of fault. Okay, next slide.
Good evening, everyone. This slide highlights the core components of securing our network post-merger. We've implemented network segregation using VLANs and access control lists to tightly control traffic flow between segments. This limits the attack surface and enforces security boundaries. We've also strategically distributed data center resources between LANs, which helps ensure that each department or function only has access to what they need. Another key piece is the TAXUS Plus. This protocol gives us centralized control over authentication, authorization, and accounting. With TAXUS Plus, we can log every administrative command on network devices, making audits and incident reports much easier. We also enforce strong password policies on every device to reduce brute force risk. Finally, we operate by the principle of least privilege, ensuring that users only have access to the resources necessary for their role. This is especially important in preventing insider threats and accidental misconfigurations. Beyond logical controls, we've taken the steps to secure our physical infrastructure and network perimeter. On the left, we emphasize physical security. This aspect would include secured server rooms, locked racks, badge access, and surveillance systems. This helps prevent unauthorized physical access to critical equipment. In the middle, we see network firewalls. All traffic entering or leaving the network passes through a firewall, where it's inspected, filtered, and logged. These devices are configured with strict rule sets that limit exposure to external threats. On the right, the possibility of implementing honeypots. These are decoy systems set up to detect and deflect cyber attacks If someone tries to breach the network, the honeypot attracts them and alerts our security team. This proactive measure would allow us to study attacker behavior and react quickly. So we can help secure our networks by having our employees be aware and properly trained to know what to look for. And the principle of least privilege limits access and only allows a user what they need to perform their role. I would like to thank you for taking time to listen to our presentation, and have a good evening.